It's time to take smart heating to the next level with Sonoff. Hey guys, what's up? I'm super excited because finally I get to share my DIY smart heating. It's the third year in operation, so I guess it's 3.0, and it's been a long way. Yes, it still looks like something that probably at some point going to explode, but I'm going to fix it at some point. I know I've been saying that for 2 years, but I've been so focused on the software side of things that, well, let's face it, I left it there and it never bothered me, so I guess it's okay. But in case you don't know what I'm talking about, in this video you're gonna find out how to change your 30-year-old heating system into smart heating system for $5. As it's a third year and the third iteration, things go bigger, better, and as you could imagine from that shower of Sonoff sensors, a little bit more expensive. But while the original system still costs you $5, it's worth investing in more sensors so you could achieve stuff like this. Alexa, set heating to 17.
Is set to 17. Sure, I'll keep the office warm for you.
And I know what you're thinking, Amazon Echo integration, it's nothing new, but hold on a second, there's a couple of things that actually just happened. First of all, I obviously set the home heating, well, my 30-year-old home heating, to desired temperature. The second thing that happened, actually, the sensors in this room took a charge. So right now my home heating is monitoring the temperature in this room specifically. If I issue commands from a different room, it will also do the same thing. It will set the temperature of that room specifically and will monitor it. What do you think the advantage is? I don't have connected radiators just yet. This is something I'm planning to do springtime. It's cold outside and I don't really feel like draining my radiators in the middle of winter. That's not advisable. Why am I bothered with this? This is because I have different rooms that heat up at the different speeds. And predominantly it's for my wife because her office is the smallest and heats up the quickest. So when she works from home and it's still lockdown in UK, her room heats the quickest, and having the thermostat and the temperature in another room causes this room A to overheat, B to heat up entire home way too much and, well, lose the money in process. So he got me thinking, how about we're going to take advantage of whatever tools I've got available and build a DIY heating 3.0. To turn your traditional and not so smart heating into a smarter one, you have to rewire your thermostat. Don't worry, this is not that difficult and I've completely covered this in my previous video, so I'm just going to jump ahead and focus on the new functionality. And in this case, we're going to talk about adding more sensors to the system. So why Zigbee? Come on, you probably watched my videos before and you know I'm super excited about Zigbee and it's great for that scenario. It supports mesh and networking, which means that you're less likely to end up with dead spots across the house. I'm going to kit out each room with Sonoff Zigbee sensors for temperature and humidity. Why Sonoff? There's a couple of actually advantages for using these particle sensors. First of all is the increased battery. They use 2450 CR2450 batteries, which are 3 times bigger than the normal batteries seen on those temperature sensors. So that will assure that the sensor actually gonna last much longer and it's less hassle to actually monitor the battery use, etc. I already have this covered because I've developed a system that monitors the battery of all Zigbee devices for you. I'm going to link it in an article too. Another great advantage of using actually those Sonoff sensor is, well, the price. They're inexpensive, they cost around $7 to $10 depending where you shop and what the promotion is like. I'll include the link to them in the description of this video. But if you're going to kit out like 6 or 7 different rooms, well, let's just face it that the cost quickly adds up. Apart from temperature, they provide you with a humidity metrics, and I know some of the sensors also give you a pressure if you want to get that reading, but I'm going to supplement the pressure readings from Weather API. By the way, don't worry if you for some reason don't want to use them. The system is compatible with any Zigbee temperature sensors, so you can use existing sensors as well, and you can mix and match different sensors from different brands. Something definitely to consider is the placement of the sensors. As you can see, this one is placed near the window, something you should definitely not do, as the temperature between one place near the window or one place near the radiator can be quite significant. As you can see in this case, almost 3 degrees. Find a spot that is far away from the radiator and the window and possibly located more or less at the height of your head. That way you'll always have a representative value for your temperature in the room. This project is going to be split into 3 parts. I would strongly advise you at this point to hit subscribe. I know I never say that, but hit subscribe or follow me on social media if you're interested how I'm going to build on top of that, because there's a couple of very exciting things coming up. So the next step of this project is to deploy PIR sensors, and we're going to use them to create a score for each room. That score is going to be developed over time, so it's going to have a 24-hour breakdown, and we're going to use this score to recalculate the temperature for each room and perhaps use this score to figure out when the rooms should be heated. While I'm pleased that these Sonoff PIR sensors come with a bigger battery, I don't think that's enough, especially if the polling rate in some rooms is going to be quite high. So I'm going to develop a 3D printed enclosure that's going to take 2 AAA or AA batteries, I'm not 100% sure which ones, and that should extend the battery life of these devices even further. So stick around because it's going to be a separate write-up on that. I'm really keen on developing the sensors into a network of sensors that's going to eventually calculate a occupancy score for each room, something I really desire to use with machine learning. And in a third part of this project, we're going to focus on schedules, or weekly schedules to be precise, because I found really cool sliders that you can set to start heating up your house this way. I know the timers aren't exactly focused on this project because I would like to use the room score instead to drive the heating automatically and never have a need to set a timer. So this is something that's going to be running alongside, but it's more afterthought than actual main feature of the project I'm working on, especially if I'm going to later on use that data to process with machine learning and figure out if I can drive a heating this way. Let's talk about features, and as you can see, a couple of things has changed. While I'm still keeping on this thermostat, which looks like this, there's a lot of things that have been added to it and works in the background. So let's talk about these. First of all, you're gonna see buttons available for each room. I can switch between set points. So for example, right now I'm trailing the sensor of the temperature that is located in the kitchen, or right now I'm doing this one, or it's located in a study. When I click on it, the updates happen every 5 seconds. Now notice different colors right now in here. Gray means that the temperature of that room is below the temperature of the set point. Set point is set to 17 degrees. This is 16.71, so it's lower. Now anything higher, it's going to be set to orange, and the red is obviously the room that is set as the room with the temperature that we're trailing. Now you can change this from buttons in here, or you can call Amazon Echo commands. Now in future I'm going to implement the score for each room being calculated thanks to the PIR sensors, so that's going to be helping out setting this as well. Now you'll see that if I'm going to change the target temperature, those colors are going to change as well. So right now all rooms are hotter than 15 degrees, and if I can start raising the set point temperature, you'll see that those change. And I'm doing this because I'm setting myself up for adding a thermostatic control for individual radiators. So you will see I will be able to control which rooms should be heated up. It's already built into a software. Obviously you've got basic controls, which is turn on and set away when you're leaving, etc. I've played with Grafana a little bit, and you can see a lot of charts in here that are available. Now every single room has available charts for temperature, pressure and humidity, and you can display them with 1 hour, 12 hour, 24 hours intervals, and also the data from yesterday and today. In addition to that, I have a hourly hourly use of the thermostat. I have a daily use for the heating with a kind of breakdown when the heating was being in use, and then weekly use, which also calculates how many total days in the last 7 days are used heating of. It's winter, so the values are quite high. Below that, I have a thermostatic chart. So it basically what it does, it draws the current ambient temperature from the rooms that being set as my set points or my targets, and obviously the red one is the set point from the thermostat itself. To the right hand side you'll see individual rooms, and those are right now in the temperature mode. So in the temperature you'll see the temperature outside. It was quite warm today considering it's winter. It's 8 degrees. There was a dipping a couple of days ago, it's dipping under 0. There is a temperature for room and obviously the target, so how my thermostat was set and how it was affecting the temperature in each room. You'll see those things are changing. So let's switch them to 24 hours to give you a little bit more information, or you can see like a little bit more granular information. So that's last couple of hours with intervals of hours. You can also zoom in on individuals if you want to as well. Now let's jump to pressure mode and display information in the pressure. So if the sensor doesn't have a pressure mode, then it's taken the pressure from outside. So that's how it works. To see the changes, it's best to go into 24 hours, and you can see that the pressure was dropping. And if the charts look similar like this one and this one, I'm using the pressure from Weather API. For this one, I'm using the pressure from sensor. And lastly, there is a humidity if you want to monitor humidity, and kitchen is going to be a perfect example to see what time I've been eating and cooking. So I had something in the morning and I have something in the evening. So that shows you the humidity outside and humidity inside the room. It's a good thing to kind of monitor if you want to be on top of your humidity in rooms, so prevent damps. You can also set alarm with Grafana's, etc. So that's basically all you have available on the dashboard right now. I've used Influx database and Grafana to display the charts. Those are actually embedded into here, so I don't have to change the dashboards and jump between the screens. It's much more comfortable this way. There's a couple of options you have to change in order to do it, but there is a separate tutorial about InfluxDB and Grafana, so I would strongly recommend you to visit my page and it will walk you step by step. In order to generate all that information, you just go to Grafana and set it up to show the information you want in particular room. So I've generated a set of dashboards for temperature, for humidity, for pressure, and also separate ones that I was toying with. So I have my hourly use, daily and weekly. I have this kind of heating pattern, so I could kind of see what time slots I'm using the heating, and my thermostatic information when I was using the heating, etc. So that's the charts I'm using, and those are simply embedded back into the dashboard from Node-RED. So actually the flow isn't that complicated. I managed to organize it, and there is only a couple of things that you have to set up. First of all, you're going to start with preferences, so go to the setup and take a look at these. In here you'll have to only set really the sample lead. So this is a name of the room that you're going to fall back should anything go wrong. And you could also set default temperature. So if you're just going to use the command turn the heating on, you will set that temperature to 20. So if you want to change that, modify it in here. That's pretty much done. Because this system in theory supports unlimited number of rooms, you can add as many rooms you want. Now I'm using Sonoff sensors in particular for a couple of reasons, so you will be able to submit the data from whatever sensors you've got, or even mix and match. Some of the sensors will report the temperature more often or less often, so I have a limit node because as it happened, a couple of sensors were reporting from different brands every 30 seconds, but also sending a couple of payloads, which I didn't like in my scenario. So I've placed a limit node, and I'm only do one message every 30 seconds, and that's the top I can receive. Now the switch node in here is quite important because you'll have to set a couple of things. First of all, if your temperature, this is coming from Sonoff Basic, is stored in a different payload, you have to put it in here. So you'll be able to set a room name, a temperature path to wherever temperature is stored, humidity path to wherever humidity is stored. Now, if your temperature sensor has a pressure, you set it to pressure path, otherwise set it to false, and you will pull information from weather API instead, because let's face it, unless you live on a skyscraper, your pressure is going to be very similar to whatever's reported in your local area. If you have a battery information, you can also include that. This one is connected to a Sonos, so it doesn't use the battery information. Link is about signal strength. Again, just put a path to your signal strength, otherwise use false. And lastly, Grafana, there is a JSON in here which contains URLs for Grafana. So you will need a Grafana panel ID and the URL for individual charts. So there is a one for temperature, one for humidity, and one for pressure. So these charts need to be pasted in here. You will also need a weather API. I'm using Opera Weather Map, and in a setup you can uncomment this and set up your API, latitude and longitude for your location, and you'll be able to get information about the weather every 5 minutes. The account is also free, so you're not paying anything for it, and that sets this in information about your weather, so you can see the weather conditions here. Okay. Next up, all the data from sensors in here and all the data from weather, it ends up in my home automation database in InfluxDB. That is done automatically. The only thing you have to do is just set up your home automation database and connect it here. The tutorial is going to be linked for you for that, the one I've mentioned when I was talking about Grafana. A nice thing is that all the information about the sensors are actually sent to this array in here. It will, for each room, you're gonna have an object created with all the information about this room and whatever you really need from that sensor. So that's gonna happen automatically, and for the most part it's gonna be processed automatically as well, so you don't have to worry about. In a dashboard there will be a couple of things that you have to set up. Now, first of all, if you're gonna go to a thermostat controls, so you remember I had a usage for day usage, for hourly usage and weekly usage, so you have to submit URLs via payloads from here. So modify each inject node and you're gonna have your usage available in these sections here. Now, next up, you have to modify the build template for room charts. So for each room, I have to build a template. And for each room, you'll have to create this small script. When it tries to set a data payload from an array, and then it sets a message room 1 to null if it's an error. Now, you have to copy and paste that as many times as many rooms you have, and for each one you have to iterate the data. So you'll see this is room 1, for room 2, room 3, etc. And order you should be taking from here. So this is room 1, for 2, 3, etc. So that's how it works. And once you're done with that, the second thing that you have to modify, you have to put that into corresponding table cells. So you can see this is a cell and this is a row. So for each cell I need to copy this script. This you can copy it from my write-up, which is linked in the description of this video. I'll explain a little bit better, but what you have to pay attention are the names in here. They're going to be corresponding to whatever you had in a build template, and obviously the number of cells should correspond with the numbers of the rooms you've got. Exactly the same principle goes for humidity and pressure generation of the charts. So just open these, create as many try and catch scripts as rooms, iterate the data in here and use the data from the numbers of the rooms, and then create a template in each cell of which contains the names associated with these. That's basically all you need to do. Okay, it's time to jump to smart controls. You don't have to really set anything, but if it's your first time with either Nora or Alexa Skill, then you probably have to set it up, and I have corresponding tutorials on my website. Just go there and pay more attention how to set it up and come back to here for explanation. Now, for the most part, I'm not doing anything new with my Amazon Echo devices, but I'm using Alexa Remote to actually listen to what I say to my Amazon Echo devices. Now, if I say anything that has set and heating in it, it will take information about which device it was responding to it and set that as my room, which is going to be a target room for the heating. And then it will send a custom voice memo saying that this room is going to be heated up for you. This is only available for Alexa devices. It's not available for Google Home, unfortunately. And if you're using Google Home, it still works with the system. It updates information that you set either via dashboard or via Google Home widget. So there is no problems whatsoever with this. So let's take a look at how it works from that end. Let's set the temperature to 21, and as you can see, if I go to thermostat, it's set to 21. If I want to disable the heating, I just need to lower it to 18, and I'm gonna have 19, which is basically rounded up for here. And that's basically it, and you can see it works quite well. The next part of this project should be done by the next weekend, so if everything goes well, you should see that on Monday. Unless things won't work as I predict them to, and then you'll have to wait a couple of days. And lastly, a week later, we're going to focus on timers and schedules, so if you desire to have this one as well, I guess stay tuned. Another thing that I should take in consideration is my Zigbee mesh. Right now I'm running on CC2531 coordinator, and that's fine and supports everything that I'm running at it and all the temperature sensors, no problems. But as soon as I'm going to start deploying PR sensors and connected radiators, I think I'm going to overload my network, and that's why I'm looking into the CC2530 instead, which is greater. I actually ordered 3 of them, so I'm gonna be writing about building up the mesh in a bit. I know I'm such a disgrace because I have those lovely devices. This is VO Terminal and this is M5 Stark Core. I should really pick one or the other and use them as my thermostat and change that ID looking device into something pretty, especially that I already have a 3D printer. Now, which printer? It's Ender 3. You can click in there if you're interested. But I promise this year I'm going to actually do it and change the interface, and you'll be able to admire thermostat on one of these screens. Not sure which one yet. Alright guys, thanks so much for watching. Leave me a comment with what do you think about this heating system and what other features you would appreciate. I'll definitely read all the comments, and I do appreciate sharing you this video with your friends and everyone around, because I've put a lot of work to make it happen. As usual, there are social media on the screen. You can use them to follow me if you're interested in other things I do. And I'll see you next week if you're interested in this project, and probably sooner if you want to watch other my content. Take care. Bye. I don't think I can hold all of this together, but I'm going to do it. I'm only going to do it once.